Hello everyone, my name is Shy Hires and I'm here today to talk about the role that database relationships play in data integrity. This presentation will consist of topics such as cardinality, connectivity, and relationships including one-to-one, one-to-many, zero-to-many, zero-to-one, mandatory, optional, identifying, and non-identifying. What is connectivity and cardinality? Connectivity is the relationship between two tables. The four types can be seen in the image to the right. In a one-to-one relationship, there must be one and only one entity connected. The representation of this looks like two dash marks. In a zero-to-one relationship, there can be zero or a maximum of one entity connected. The representation of this looks like a zero followed by a dash mark. In a one-to-many relationship, there must be at least one entity, but there can be more. The representation of this looks like one dash mark followed by what is known as crow's feet. In a zero-to-many relationship, there can be zero or many entities. The representation of this looks like a zero followed by the crow's foot. Cardinality tells us how many entities are connected in our database. It's like saying, for every one thing in the table, how many things can be connected to it in another table? It helps us understand the minimum and maximum number of connections one entity can have with another. Here's a scenario to put all of those puzzle pieces together. For this scenario, we have a database that stores data about the professors at Georgia College and the classes that they teach in a semester. In this database, you have Table 1 to the left, which stores the professor data, and Table 2 to the right, which stores class data. In this example, you have the word teaches in the middle to show that a professor teaches the course. To the right, you see that there is a one-to-one connection, meaning that one and only one professor can teach the class. To the left, you see that there is a one-to-many connection, meaning that a professor may teach at least one class or many classes. Now, to delve more into the relationship constraints between tables, we'll talk about the mandatory and optional relationships. In the mandatory relationship, one entity occurrence requires a corresponding entity occurrence. This could be represented by a one-to-one relationship or a one-to-many relationship. You can think about it like this. It is a mandatory relationship because it is mandatory to have at least one of the entity. In an optional relationship, the parent table, which holds the primary key, does not need to have a corresponding child table, which holds the foreign key occurrence. This could be represented by a 0-to-1 relationship or a 0-to-many relationship. So you can think of it like this. It is optional for the parent table to have a connection with the child table. Here is a new scenario to show the usability of mandatory and optional relationships. For this scenario, we have a database that stores data about customers and the orders that they purchase. In this database, you have Table 1 to the left, which stores the customer data, and Table 2 to the right, which stores the order data. To the left, you see that there is a one-to-one connection showing that an order record must have a valid customer because without the customer, there cannot be an order. To the right, you see that there is a 0-to-many connection showing that a customer does not need to have an order to be a customer. The last topic that we will discuss is identifying and non-identifying relationships. In an identifying relationship, the primary key contains the foreign key, and it is represented by a solid line between the tables. A non-identifying relationship does not contain the foreign key in the primary key, and it is represented by a dotted line between the tables. In this example, the relationship between the two tables on the top would be a non-identifying relationship. You can see that there is a dotted line between them, and the foreign key is not contained in the primary key. On the other hand, the relationship between the two tables on the bottom would be an identifying relationship. You can see that there is a solid line between them, and the primary key contains the foreign key. So why is all of this information important to database development? The requirements gathering process is very important. and its results should be verified by the user before the database design is built. If the business rules are incorrect, the design will be incorrect, and ultimately the application will not function as expected by the users. For data integrity, these concepts help to ensure that data is accurately represented and maintained within the database. By defining the relationship between entities and specifying constraints, developers can prevent data anomalies and inconsistencies. When it comes to queries, understanding cardinality and connectivity, developers can optimize database queries for performance, minimizing resource usage and response time. This is the end of the presentation. I hope that you will find the information that I presented to be useful for your future database endeavors.